Welcome DP Sogong aboard. Your learning journey starts now. Ever wonder how we actually build a model of the world? Not just copy it, but truly understand it. Most systems try to predict or list things, but they often start with assumptions. Objects exist, dimensions are fixed. But what if the real magic is in the relationships, not the things themselves? That's where semantic mathematics flips the script. So how does this magic work? It boils down to 5 core ideas captured in the DIKWP framework. Think of it as the DNA of understanding. First, the same semantics. We group similar experiences, like seeing darkness repeatedly. Then different semantics. We notice differences that matter. Does changing the switch affect the light? Crucially, it has to change the outcome. Next, complete semantics. This is about finding the full picture, the complete rule that explains everything within our current scope, no exceptions allowed. W is value ordering, deciding what matters most when choosing actions. And finally, P purpose. This isn't just a goal, it's an active transformation from the current state to a desired future state. It's not just predicting the weather, it's deciding whether to carry an umbrella based on your purpose, staying dry versus saving energy. This whole system is dynamic, constantly updating based on new observations and purposes. Okay, let's see this in action. Imagine trying to figure out why a room gets bright. The system starts by grouping all the dark moments together, D, and all the bright ones, D again. Then it gets clever. It tests interventions. What happens if I change the curtain, the switch, the daylight? Only the changes that actually affect the brightness count as different semantics, I. It systematically eliminates irrelevant factors like the book on the table or the phone ringing. Then comes the crucial step, building a complete knowledge, K, that perfectly predicts brightness in every single scenario it hasn't seen before. This K isn't just a guess, it's rigorously tested. Existence here isn't about metaphysics, it's about function. A lamp exists because it can reliably make the room bright under certain conditions. Music doesn't change the light, so it doesn't exist in this specific relational context. EXCR and ESEX are tools to ensure we're tracking the real meaning behind names or symbols, not just memorizing words. It's about the invariant relations, not the labels. Now let's talk results. This wasn't just theory, it was put through its paces in a simulated world with over 1,000 possible states. The task? Figure out what makes a room bright. Using this DIKWP approach, the system correctly identified the 5 key factors: daylight and open curtain, or power, switch, and intact lamp. It built a complete knowledge K that nailed every test case. When faced with the same dark room, depending on the purpose P, it made different choices. Flip the switch for speed, or open the curtain for minimal energy use. The kicker? This system achieved perfect accuracy using only the relevant information channels. Other methods, even those drowning in data, stumbled. This shows the power of semantic tuning. Focusing on the right relational pathways, not just collecting more data, leads to deeper understanding and better decisions. Less noise, more signal. So why should you care? Because this changes how we think about AI and cognition itself. It moves beyond just predicting what happens next. It embraces the messy, active process of human understanding, observing, comparing, forming concepts, weighing values, and acting to change the world. It acknowledges that our understanding isn't static. It evolves, revises its own categories, even adds new dimensions when needed. While we're not claiming this equals consciousness, it offers a powerful new lens for building smarter systems and understanding our own minds. The core takeaway: the world isn't a fixed list of things, it's a dynamic web of relations, constantly being interpreted and reshaped by us. Pretty cool, huh?